Okay. So whenever we put our username and password, our credential will authenticate. And this AP is not responsible for authenticate your credential. There is something different. In the company, there is a server. There are multiple servers. For example, in some companies, there are server called Active Directory. I hope someone if knows or not. That is called Active Directory. So basically, these are the servers where all the company's employees' credential is stored. Every employees, either you, either the manager, either the director, everyone's credential is stored where, guys? At the Active Directory servers. So whenever you trying to connect with any devices which is located in your company, your credential will authenticate with that server. Now, how this AP will forward your request to that server? That comes under, guys, wireless architect, wireless infra. Because here access point, after access point will forward your traffic towards, for example, if you are using the Meraki, if your company is using the Meraki, for example, there is a Meraki dashboard, your AP will forward your request to the Meraki. Now what Meraki will do? Meraki will forward to your packet towards the Cisco ICE. Cisco ICE will forward your traffic towards the Active Directory server. In Active Directory server, maybe nowadays we are using any protocol, any technology. For example, one login. If anyone know, one login, that is a third party. One login. One login is the third party tool nowadays. That is also very trending. Maximum companies nowadays using the one login. In one login, generally, we have a UB key. I hope, did you guys see UB key, how UB key looks like? One login. Is this visible? Everyone, are you able to see?
YubiKey is that correct?
Yes, that is called UB key.
Thanks.
That is also used for the authentication. You need to insert this one. This is like a USB slot. You need to insert this inside your computer, and here you need to put your finger. Getting my point? And by your finger, you can authenticate yourself. Yes, that is the correct person who is logging in your computer. Getting my point, everyone? Yes or no? So that UB key facility is provided by the one login. So one login is the third party tool nowadays we are using for the authentication. So in one login, there are two things by which you can authenticate. First one, by code or by this UB key. You see now? I hope this is able, I hope you guys are able to see this one. In UB key, generally, you guys will get the option. You guys will get the option. See, there is something different. See, I think this one. See, this is the last option where UB key is there. But in one login, see the first option. What is this? One login protect. One login protect. This is the application. This is the application, and this application is managed by one login. So what you need to do? You need to install this application in your phone, and once you try to connect your laptop with your official devices, what you need to do? You will get the code. You will get the code in your phone, and you need to put that code in your laptop. So this is the way you can authenticate. But nowadays, maximum companies move towards the UB key because this is the more secure. Getting my point? Because here you will authenticate yourself by finger, not code, because there is a chance we can share the code with anyone, right? So nowadays, maximum companies move towards the physical device that is called YubiKey. Okay, so that this is the way we can authenticate. Yes. Now the thing is, in wireless architecture, that is very important how we are going to authenticate ourselves. And that comes, guys, under the wireless architect. Because in wireless architect, there are multiple things. We have a Meraki, we have a Cisco ICE, we have a Active Directory servers, we have a one login. There are multiple things. So that is called, guys, wireless. And guys, the last one, that is called automations. So in automations, we are going to discuss the overview of automations, how actually we can automate the thing. For example, what is Ansible, what is the Terraform, and how's the automation impact nowadays the network. So these are the things we are going to discuss in our automations part. Clear, guys? I hope you guys understand. Tell me, is this clear? Okay. Okay, guys. Now come to our one topic that we are going to start. I hope my screen is visible to all of you. Please let me know, guys.
Yes, the screen's visible.
Very good. Guys, that is types of communication. Guys, generally, there are total 3 types of communication. First one is called unicast. Second one is called multicast. And the third one is called broadcast. There are 3 types of communication in the network: unicast, multicast, and broadcast. Unicast is known as, guys, that is called one-to-one communication. That is called one-to-one communication. And multicast is known as one-to-many communication. And broadcast is known as one-to-all communication. So basically, guys, there are 3 types of communication in the network: unicast, multicast, and broadcast. Now, we need to understand what is the meaning of this. Now, see here. For example, that is my PC number 1. That is my PC number 2. We connect PC number 1 and PC number 2 like this. PC number 1 is sending anything or any data towards the PC number 1, and PC number 2 is sending anything towards the PC number 1. For example, PC number 1 is asking anything and PC number 2 is replying anything. So now tell me one thing, guys. This is called one-to-one communication. Agree, everyone? Yes or no? Arey, this is happening one-to-one communication. Yes, na everyone? Yes?
Yes.
That is called unicast. That is called, guys, unicast. So how can you define the unicast, guys? Unicast communication basically involves sending the data packet from one sender to one specific receiver. That is called unicast communication. Is this clear to all of you? Everyone. So PC number one is sending the data to a specific user. That is called PC number two. And PC number two is replying with data to a specific user. That is called PC number one. It means during the sending time and during the receiving time, the device is specific. So that's the reason this is called unicast communication. Clear, guys? Everyone. Understand? That is called unicast communication. Now come here with the multicast. In multicast means, guys, one to many. One to many. How can we define the multicast first? Guys, how can we define the multicast first? So, multicast communication involve sending data packets from one sender to multiple specific receivers. That is called multicast communication. Again, I am telling, see here. For example, that is the PC number one. For example, there is a switch. And with this switch, multiple PCs are connected. Multiple PCs are connected like this. For example, these are in group number one and these are in group number two. If this PC is sending the packet reach on switch is forwarding towards here and here, not here. So this type of communication is called, guys, multicast communication. In multicast communication, we are not sending our data to all of the device. We are sending the data to a specific device. That is called multicast communication. Is this clear to all of you? Everyone, tell me. Multicast means just sending our packets to sending our data to many devices, not all. That is called multicast communication. For example, I don't know you guys know or not. For example, that is the router. On router, we are using, for example, any routing protocol like OSPF. I'm just telling you, okay, na? If you don't know, don't worry about it because in our routing classes, we are going to cover. I'm just telling you for your information. With this router, for example, we connect multiple devices here. For example, here our PC1, PC2, PC3, PC4. And for example, here I am running the OSPF, here I am running the OSPF, and here I am running the OSPF. It means all the three, P1, P2, P3 will share the resources with each other with the help of multicast, with the part of multicast. That is called multicast communication. Getting my point? Understand? You guys will understand multicast in more depth when we will discuss the routing protocol. Basically, OSPF is the routing protocol that use the multicast address. Okay. So multicast address means, just understand, to share the data to multiple devices, not all. Clear, guys? Now, come to the broadcast. Broadcast means, guys, one to all communication. So in this communication, what will happen, guys? Our data packets will forward from one sender to all the devices in a network. That is called broadcast communication. I'm giving you an example. For example, that is the switch. With this switch, multiple computers are connected. Multiple computers are connected. Now, if this PC, and this is, for example, PC number 10. Here I am using the IP address, for example, 10.1. Here I am using the IP address, for example, 10.10. This is for your example only. Now, for example, here I am writing the command ping 10.10. It means I am trying to reach from PC 1 to PC number 10. I am trying to reach. In this case, guys, I hope you guys have some idea. For example, if we are trying to ping any devices, we want some information. Yes or no? Everyone, tell me first. Tell me, guys, yes or no? Guys?
Yes,
Yes. Yeah.
Exactly. For example, if I want to send anything to Ahmed Ismail, if I want to send anything to Ahmed Ismail, I definitely, without his address, am I able to send anything? Answer is no. I am not able to send anything to Ahmed without knowing his address. Getting my point? Yes, na? In the same way, if PC number 1 wants to ping PC number 10, if PC number 1 wants to ping PC number 10, so without knowing the address, how PC number 1 will forward the packet? This is possible. Answer is no. That is not possible. Getting my point, everyone? Yes or no? Yes. So in this case, PC number 1 must know two things. What is the PC number 10 logical address, and what is PC number 10 physical address? These are the two information PC number 1 must want. Without these two information, how PC number 1 will reach PC number 10? That is not possible. Getting my point, everyone? I hope you guys understand. Right? Now, logical address means, guys, logical address means IPv4 address. For example, I am writing IP 10.0.0.1. That is called IP address, and IP address is called logical address. Clear, guys? Everyone. And physical address means I'm talking about the MAC address. Clear, guys? So there are two types of address in the networking: logical address and physical address. Logical address means we are talking about the IP address, and physical address means we are talking about the MAC address. Clear, guys? Everyone? Yes or no? Done? Now,
yes,
when I write the command ping 10.0.0.1, sorry, ping 10.0.0.10 here on PC number 1, it means by itself, by ourselves, I am telling PC number 1 ki, hey, you need to ping PC number 10 and this is the IP address 10.0.0.10. This is the IP address of your destination device. It means I am itself telling PC number 1 about the logical address. Agree, everyone? Yes or no? Right? Right, na? I am telling by itself, na, PC number 10, what is the destination IP address? That is the destination IP address. I am telling by myself. Yes or no? Guys. Yes, na? So PC number 1, no. What is the destination IP address? That is 10.10 because I provide the destination IP address to PC number 1. Now, PC number want physical address also. Physical address means MAC address of PC number 10. Now tell me one thing. Whenever we are pinging any devices, are we write the MAC address? No, we are not writing the MAC address. We are always pinging the IP address, right? Everyone. We are always pinging the IP address. We are not pinging the MAC address, right? Na? So, in this case, your PC number 1 don't know what is the MAC address of PC number 10. Getting my point? Yes or no? Because you provided logical address 10.10 address to PC number 1. You didn't told PC number 1 ki, hey, this is the MAC address of PC number 10. No. Getting my point, everyone? Now, without knowing the physical address of PC number 10, PC number 1 is not able to ping. So in this case, PC number 1 must know what is the physical address of PC number 10. So in this case, there is a process that is called ARP. I will tell you later in a very detailed way. PC number 1 will generate the ARP. Right now, I just want to tell you ARP is nothing. ARP stands for Address Resolution Protocol, and the main use of ARP is to find out the destination device MAC address. That's all. So PC number 1 is sending the ARP, and this ARP responsibility is to find out the MAC address of PC number 10. So when PC number, there are two types of ARP. ARP request and ARP reply. Now PC number 1 sending the ARP. So guys, tell me, this is the ARP request or ARP reply? I am asking to all of you. When PC number 1 is sending the ARP, so this is ARP request or reply. Exactly. That is request. For example, if I am asking anything to you, it means I am requesting you. And whatever the things you are telling me, that is called reply. Getting my point? So PC number 1 here wants the MAC address of PC number 10. So PC number 1 is just requesting to PC number 10 ki, hey, I don't know what is your physical address. Could you please tell me? And PC number 1 is asking this information by the help of one message that is called ARP request. So guys, PC number 1 is sending the ARP request. This ARP request will reach on switch. What switch will do? Switch will check, I am receiving this ARP request here on this interface, on this port. And that is called switch port. That is called, guys, switch port. That is the switch. There are, I told you how many ports are there on the switch generally, guys? 48 port. And all the port on the switch is called switch port. So definitely this is also a switch port. So this switch received the packet on this port, and that is called switch port. Now switch will check, I am receiving the ARP request here. And you know, switch also don't know what is the MAC address of this device. So what switch will do? For example, try to, guys, everyone, my teaching way is something different because I'm trying to relate each and everything in with the real time scenario, because I'm working as the network administrator, so I know how the thing is going on. So try to relate with me. Maybe I'm giving you a very, very basic example so you guys can relate with me. For example, there are in our group, in our WhatsApp group, there are more than 15 or 16 members are there. And for example, if one guy is asking me anything, and if I don't know, so what I will do, I will ask to the group, hey, anyone know these things? It means I am just broadcasting this. It means I am asking to everyone in my group, hey, if you know anything about this, please let me know. In the same way, here switch is not know what is the MAC address of this device. So what switch will do? Switch will just broadcast this ARP request to here, 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 here. Now switch is asking to every devices who is connected there with the switch ports. Getting my point, everyone? Yes or no? Understand? Now, this ARP request came here, 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 here on every device. For example, this ARP request come here on this PC. This PC open this ARP request, and this PC check what is the destination IP address. In this ARP, what is the destination IP address, guys? 10.10. Now this PC will check in this packet, destination IP address is 10.10. Now this PC will check what is my IP address. Now this PC will find, oh, my IP address is 10.5. But in this packet, destination IP is 10.10. It means this packet is not belongs to me. This packet is not for me. This PC immediately drop this packet. Similarly, this one, similarly, this one, similarly, this one. All the other PC will drop this ARP request. Only this PC will accept the ARP request, because the destination IP is 10.10 inside the packet, and the local IP address which is configured on this PC is 10.10. So this PC accept this packet. It means this is the only PC who is responsible for ARP reply, who will generate the ARP reply. Getting my point, everyone? Are understand, everyone? Yes or no? Right now, these PC are not going to generate the ARP reply because these PC drop that packet. And this PC will generate the ARP reply. Now, in this ARP reply, what will be the source IP, guys? Source IP will be the IP address of that machine who is sending the packet. That is called source IP. So for who is generating the ARP reply? This PC is going to generate the ARP reply, right? Everyone. So this PC IP address is called the source IP. Now on this PC, what is the IP address we have? Who can tell me? On this PC, we have a IP 10.10. What will be the destination IP address, guys? This PC wants to share this ARP reply to PC number 1. So destination IP will be, guys, 10.1, PC number 1 IP address. Now, again, source MAC. Source MAC means MAC address of this PC, local PC. So what is the MAC address of this PC? For example, 0D. So source MAC will be, guys, 0D. Now, what will be the destination MAC? Destination MAC means the MAC address of which device? Destination device. This PC is going to send this packet to which device? PC number 1. So for this PC, who is the destination? PC number 1 is the destination. Yes or no? Right? So destination MAC will be PC number 1 MAC address. So PC number 1 MAC address will be. Now again one thing you guys will ask is, sir, does this PC know what is the MAC address of PC number 1? Answer is yes. This PC know what is the MAC address of this device. Why? Because, focus here guys. Focus here. Very, very important. I told you when this device send the ARP request, in this ARP request, this PC number 1 send 4 information. What are the 4 information? Source IP was 10.1. Destination IP was 10.10. Right? Now, what is the source MAC address? Source MAC address is 0A. For example, PC1 MAC address is 0A. 0A. And destination MAC address, this PC don't know what is the MAC address. So 0000. This packet reach here, switch forward this packet here. So when this ARP request come here on this PC, what this PC will do? This PC open this ARP request, and in this packet, this PC already check what is the source MAC address. 0A. It means this is the MAC address of which device? PC number 1 device. Getting my point? So by this way, this PC already know what is the MAC address of PC number 1. Getting my point? Everyone, anyone here who do not understand? Anyone? Is this clear to all of you? I am asking, is this clear to all of you? How you guys are understanding?
It is clear. Yes.
I hope you guys are understanding very, very well. I am expecting. Okay, cool. Now, guys, tell me one thing. For example, whenever we got a call from any known person, for example, if you get a call from your relative with unknown number, what we are doing generally? We are, after dropping the call, after the talking, we are generally save this number. Yes or no? Everyone, tell me. Right? Tell me. I'm asking. Yes. Generally, when we got a call from the unknown number, and when I received that call, and after talking, if we know, okay, that is the person, this is our relative, or this is the known person, generally we save that number. And generally when we receive the call from the unknown number, and after talking, I found, that is not for me, that is not the correct one. Do you save that number? Answer is no. Generally, we are not saving that number. In the same way, think here, guys. In the same way, think here. This PC send the ARP request. This PC send the ARP request. ARP request here. This switch forward this ARP request here, 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 here. Agree? Everyone, tell me fast. Yes or no? Right? It means every PC receive this ARP request. Request, 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 request. All the remaining PC drop this packet except this. Agree? Yes or no? Yes. Now, first of all, every PC maintain one table. Every PC maintain one table. Again, I am telling, every PC maintain one table. And the name of that table is, guys, ARP table. What is called, guys? ARP table. Every PC maintain one table. That is called ARP table. Understand? Because PC is called, guys, intelligent device. Do you think you guys are intelligent? Do you think you guys are intelligent? Yes, we are intelligent. The reason is because we have a mind. We have a brain where we are storing the things. Guys, yes or no? Right. In the same way, PC is also an intelligent device because PC maintain one table that is called ARP table. And in ARP table, PC generally store the information. Or understand like this, that is his contact book where they save the contact number. Understand? Now, when this ARP request reach on these PC drop that packet because these PCs open that packet, and in this packet destination IP was 10.10. But here, for example, here IP address is 10.1, 10.2, 10.3, 10.4, 10.5, and 10.10. These PCs will drop that packet. Why? Because their local IP address is different, not 10.10. It means these PCs will think that packet is not belongs to me. There is no need. So these PC will drop that packet. Now, very important question. Does this PC store these information, this IP information in their ARP table or in contact book? Answer is no. That is the interview type question, guys. Because interviewer will try to ask you, try to confuse you. He will ask you, hey, all the remaining PC receive the ARP. Does these all the PC make the entry in their ARP table? Answer is no. Because these packets for these PC, this ARP packet is useless because there is different address. Yes or no? Right? In the same way, when you get the call from the random number and when you try to speak, you guys will realize, that is for the unknown. So in this case, we are not going to save that number. In the same way, these PC are not going to save that number. Getting my point, everyone? I hope you guys understand. Clear? Now, here, come to this PC. When this PC open that packet, this PC open what is the destination IP? That is 10.10. Yes, that packet is for me. What this PC will do? This PC will check destination. This PC will check what is the source IP address. Source IP in this ARP request. That PC send. What is the source IP, guys? 10.1. Destination IP was 10.10. Source MAC is 0A. And destination MAC is 000. Because PC number 1 don't know what is the MAC address of destination device. Now, this PC open that packet and check. Source IP is 10.10, 10.1, and for source MAC is 0A. This PC immediately make the entry in the ARP table. Understand? This PC make the entry in the ARP table. This PC save this number in its ARP table. Now this PC is going to generate, guys, ARP reply. Now this PC is going to generate the ARP reply. In ARP reply, what is the source IP? Source IP will be, guys, 10.10. Destination IP will be, guys, 10.1. Source MAC will be, guys, this device local MAC address. For example, 0D. So source MAC will be, guys, 0D. And destination MAC will be, guys, destination MAC. Who can tell me what this PC will do? This PC will check what is the destination IP. This is the destination IP. It means this is the IP where I am going to forward this packet. Now this PC will check, do I have entry in my contact book for this IP? Now this PC will find, yes, for 10.1, I have entry in my contact book or in my ARP table. that is 0A. Now this PC may fill 0A in this packet. In the same way, for example, I want to call anyone. I want to call anyone. Understand? For example, I want to call Ahmed Ismail. What I will do? I will check my contact book. If I found the contact number, then I will immediately call the Ahmed. Yes or no? In the same way, this PC will check. Oh, I need to call 10.1. Do I have contact number in my contact book? Yes, 0A is my contact number. That fill it. That is the ARP reply. This PC send the ARP reply here. What switch will do? Switch also maintain, guys, one table. We will discuss these things later. Switch also maintain same like PC. Switch also maintain one table, and according to that table, switch will forward this packet towards the PC number 1. PC number 1. Getting my point, everyone? In the same way, switch forward this packet towards the PC number 1. Understand, everyone? Yes or no? Now, what I'm trying to explain you here, try to focus one thing. When PC number 1 send the packet, that is called ARP request. When that packet was come onto the switch, what switch did, guys? Switch forward that packet to every device. So guys, tell me, this type of communication is called unicast, multicast, or broadcast? I'm asking. When ARP request packet reach on the switch from PC number 1, what switch did? Switch just forward this packet to every PCs that is connected here on the switch port. Right, everyone? So I am asking, that type of communication is called unicast, multicast, or broadcast? Tell me.
Broadcast.
Exactly. That is called broadcast. I am asking the first time. Understand? So guys, that is called broadcast, because when this packet reach on the switch, what switch did? Switch forward this packet here, switch forward this packet to every device. And I told you, in broadcast, in this communication, that data packet will forward from one sender, that is the one sender, to all the devices in the network. These are the devices in the network. So this switch is forwarding this packet to all the devices. It means that is called broadcast. But try to focus here, guys. When this PC sending this ARP reply to the switch, what switch is doing? Switch is forwarding this packet towards the PC number 1. It means this PC, this specific PC is sending to a specific user. So that is called unicast, multicast, or broadcast? Exactly. That is called unicast. Getting my point? I hope now you guys understand the types of communication: unicast, multicast, and broadcast. Is this clear to all of you? Everyone. That is called unicast, multicast, and broadcast. Now, guys, after types of communication, we have modes of communication. There are 3 modes of communication. First one is called simplex. Second one is called half duplex, and third one is called full duplex. There are 3 types of communication: simplex, half duplex, and full duplex. In simplex, please remember one line. In this communication, data travel only in one direction, from sender to receiver only. That is called simplex. Understand, guys? Here you guys can remember one more thing. The receiver cannot send back to the sender. That is called simplex. Now, what do you mean by half duplex? Data can travel in both directions. Data can travel in both direction, but not at a same time. Not at a same time. In full duplex, guys, data can travel in both direction and at a same time. That is called full duplex. So guys, there are three modes of communication: simplex, half duplex, and full duplex. Getting my point, everyone? So simplex means basically this is the type of communication that is called one mode communication, one-way communication. One-way communication means, for example, we are watching the TV. We are watching the TV. So whatever the content we watch here, we can only watch, na? Are we able to send anything inside the TV? Answer is no. Yes or no? Everyone, tell me first. Right? Tell me. For example, anything is broadcasting over the television, over the radio. That is the example of simplex. Because the TV stations broadcast the contents to viewer. But viewer cannot send feedback to the same channel. Getting my point? That is called simplex. Now, what do you mean by half duplex? Half duplex means, guys, in half duplex, data can travel in both directions. But the problem is not simultaneously, not at the same time. Not at the same time. Getting my point? That is called half duplex. I hope you guys know something about the walkie-talkie. In walkie-talkie, generally, we are using walkie-talkie in military, for example, in the railway. So there we are generally using the walkie-talkie. In walkie-talkie, how we are talking? Guys, we are talking, for example, I want to say something to anyone. I will tell, hey, how are you? Over and out. I am telling, and at the end, I am telling over and out. Why I am telling over and out? Because I want to tell to the receiver, hey, whatever the things I am trying to telling you, my word is now finished. Now, if you want to share anything, now you can tell me. Getting my point? That's the reason we are using over and out. That is called, guys, half duplex. In half duplex means sender can send the data, receiver can receive the data, as well as receiver can also send the data. Sender can also receive the data, but the problem is not at same time. But in simplex, that is the sender, that is the receiver. Sender responsibility is only send. Getting my point? And receiver responsibility is only receive, not send. For example, we are watching the TV, and this is the TV, that is the broadcaster. Broadcaster is broadcasting the thing, but we are not able to send the feedback to them by TV. No, we can only watch the things. Now, in case of half duplex, we can send and we can receive both, but the problem is not at the same time. For example, walkie-talkie. By walkie-talkie, if someone is talking, after telling over and out, then they are able to send anything. That is called half duplex. Now, what do you mean by full duplex? Full duplex means that is sender and that is sender. It means they can send and receive. They can also send and receive. But here we can send and receive at the same time. We can send and receive at the same time. For example, right now we are connected by Zoom. I am able to ask you anything, and I hope you guys are also able to ask me anything at the same time. Right? Everyone, tell me yes or no. Right now, you do not need to wait to tell me ki, hey, over and out. Now you want to tell, if you want to tell anything, you can ask. No, you can ask me anything at the same time. Getting my point? That is called full duplex. Clear, guys? Everyone. So, guys, that is something modes of communication. Clear, guys? So, guys, basically in today's class, what we discussed what is network, what is networking, what are the future of network, and if we want to success in the networking, whatever the things we need to focus on it, right? After these things, we complete types of communication. There are three types of communication we cover: unicast, multicast, and broadcast. After that, we cover modes of communication, that is simplex, half duplex, and full duplex. Everyone, I hope you guys understand. Done? Everyone.